The box arrived on a Tuesday. It weighed 11 pounds. Inside, wrapped in brown paper and organized into labeled cellophane bags, were 437 individual components. Resistors, capacitors, a transformer, a chassis, a set of knobs, and a manual that was 112 pages long. There was no assembled product inside that box. There was no shortcut. What Heathkit was selling you was not a radio. It was the experience of building one, and the permanent, unlosable knowledge of how it worked that you carried with you when you were done. Tens of thousands of Americans opened a box like that and changed the direction of their lives. The country decided, in 1992, that it no longer needed that to happen. It has been paying for that decision ever since. The Heath Company did not begin in electronics. It began in the sky. In 1926, a Chicago aviator named Edward Bayard Heath founded the Heath Airplane Company on a belief that was radical for its time: that an ordinary American, given well-designed parts and clear instructions, could build his own aircraft at home. His most successful product was the Heath Parasol, a single-seat plane with a high-mounted wing, assembled in barns and garages across the Midwest by men who had never set foot inside an aircraft factory. For a few years, parasols lifted off from farm fields and dirt strips and proved that the idea worked. Then, in 1931, Heath climbed into a prototype he was testing outside Chicago. The aircraft went down. He was killed on impact. The company he left behind limped through the Depression and slid into bankruptcy. In 1935, a businessman named Howard Anthony bought the remains for almost nothing and moved operations to Benton Harbor, a small industrial town on the eastern shore of Lake Michigan. Through the rest of the decade, Anthony kept the company alive, making aircraft components and waiting for something to change. What changed was a world war. The Heath Company took on military subcontract work during the Second World War, producing electronic equipment for military aircraft. That detail seemed minor at the time. It was not. When Japan surrendered in the summer of 1945, the federal government was left holding warehouses full of surplus radios, test equipment, vacuum tubes, and radar components that had no further military purpose. All of it went to auction at prices that reflected the only alternative, which was scrap. Howard Anthony placed a bid. He underestimated the volume significantly. 4 railroad boxcars arrived at the Benton Harbor Freight Yard, and the station master called with a problem. Storage fees would begin in 7 days. Anthony called in every favor he had: friends, neighbors, anyone with a dry barn or an empty garage within driving distance. The parts were moved by truck and sorted by hand over the following months. Buried in that inventory were a number of 5-inch cathode ray tubes, built for radar sets during the war, and now surplus. In July of 1947, Anthony's team built a kit around them: a working oscilloscope, every component labeled and packaged, with a 100-page manual explaining each step of assembly. The price was $39.50. That is roughly $500 in today's money. A factory-built oscilloscope from a name-brand manufacturer cost several $100s at minimum. A serious laboratory model cost several thousand. The Heathkit was a fraction of either, and the only trade was that the buyer had to build it himself. The timing was not an accident of history. It was a collision with one. Across the country, hundreds of thousands of veterans were enrolling in engineering programs on the GI Bill, men who had come home from the Army Signal Corps and the Navy radio rooms with practical electronics experience and no money for professional test equipment. The O1 oscilloscope sold out immediately. Then, it sold out again. Heathkit had found something that nobody had thought to look for: a nation full of technically capable people who needed affordable tools and were not afraid of work. What the company did next was more important than the price point. The Heathkit instruction manuals were not assembly guides. They were courses. Every manual included fold-out diagrams showing the exact physical location of every component on the chassis. Each step was written for someone with no prior experience. Each major section explained not just what to do, but why. Why this capacitor and not that one? What it was doing in the circuit, how to test it if something went wrong. A college student who built a Heathkit oscilloscope in 1950 did not simply end up with an oscilloscope. He ended up understanding how an oscilloscope worked. He had touched every part. He had soldered every connection. The knowledge was not theoretical. It lived in his hands. That was the product, not the object. The knowledge that came with building it. In 1953, Heathkit entered amateur radio with the AT1 transmitter kit, and the company found its deepest customers. Ham radio operators were natural builders, technical, patient, and deeply motivated by the idea of communicating with a machine they had assembled themselves. The SB series transceivers of the 1960s and 1970s became legendary. The SB-101 alone sold in the tens of thousands. Building one required more than 100 hours of careful soldering and alignment, spread across weeks of evenings at the workbench. When an operator made his first contact on a radio he had built from a cardboard box of parts, the feeling was specific and unrepeatable. Thousands of people who are alive today still remember the exact night it happened, the call sign they reached, the distance on the map. By the 1970s, Heathkit Educational Systems was selling formal courses to high schools, community colleges, and military training commands across the country. There were courses in electronics fundamentals, digital logic, microwave theory, and eventually microprocessor programming. The annual catalog had become an object in its own right. Subscribers waited for it each year. Dog-eared copies circulated through family basements and workshops for decades. The company's peak ran roughly from 1965 to 1978, and during that stretch, Heathkit defined something larger than a product line. It defined a particular American relationship with technology. The relationship assumed that a capable adult could understand the machines in his home, that he was entitled to open them, that he should be able to fix them, and that the manufacturer had an obligation to explain how they worked. That assumption felt permanent. It was not. Three forces arrived at roughly the same time, and Heathkit could not absorb any of them. The first was a change in how electronics were manufactured. Through-hole components, the kind a human being could solder with a pencil-tip iron, were being replaced by surface mount technology. Surface mount parts were tiny, often smaller than a grain of rice, designed to be placed by automated machines at speeds no human hand could match. They were not designed to be assembled by a hobbyist at a kitchen table. The industry was moving toward a physical format that made kit building impossible for most buyers, and there was nothing Heathkit could do about it. The second force was price. In the 1950s and 1960s, building a Heathkit saved you real money over buying a factory-built equivalent. By the early 1980s, mass production had changed that math entirely. A stereo receiver that would have cost $300 as a kit could be bought assembled at a department store for half that. The economic reason that had driven a generation of buyers into the catalog was gone. What remained was the desire to build, to understand, to own something you had made. And that desire, it turned out, was real, but not sufficient to sustain a business. The third force was Zenith. In 1979, Zenith Electronics acquired the Heath Company. On paper, it was a sound deal. Zenith had capital and distribution. Heath had a loyal base and an engineering team that had been developing personal computers, the H8 and the H11, that looked promising in a rapidly growing market. But Zenith's interest was not in kit builders. It was in the engineering team and in a path into the business computer market. Within 2 years, the computer division was renamed Zenith Data Systems and was selling pre-built machines to corporate and government buyers. The kit business became a smaller and smaller operation inside a company focused on something else. The catalog got thinner every year. Product lines were quietly retired. Veterans of the company watched the contraction in real time and understood what it meant, even when no one said it plainly. In 1992, after 45 years of continuous operation, Zenith announced that the Heathkit electronic kit business was being discontinued. A company closing is not usually a historical event. What made the end of Heathkit different is what closed with it. For 45 years, anyone in the United States who wanted to understand how a radio, a television, or a computer actually worked had a clear path to that understanding. Pick up the catalog. Order the kit at a price you could afford. Spend the next several weeks building something that taught you its own operation as you assembled it. When you finished, you owned a tool and you owned a skill. The skill was transferable. The same hands that built a shortwave receiver could diagnose a failing television, troubleshoot an automobile ignition, or wire a room for a new circuit. That path closed in 1992, and nothing has replaced it. The technology in the average American home today is not repairable by its owner. The components are too small to see without magnification. The schematics are proprietary. The firmware is locked. When a device fails, the economic and legal answer is to throw it away and buy a new one, and the manufacturer has spent considerable resources ensuring that this remains the only practical option. The right to repair movement has been making this argument for nearly 20 years, with limited success, because the argument is not really about fixing a toaster. It is about a deeper question that Heathkit answered one way, and the modern electronics industry answers another. Who is allowed to understand the machines that run a modern life? In 1947, the answer was anyone willing to spend $40 and a few evenings at a workbench. The boxcars arrived in Benton Harbor, and Howard Anthony solved his storage problem by putting the contents into the hands of Americans who knew how to use them. What he built over the next 4 decades was not a catalog business. It was an infrastructure of technical literacy, assembled one kit at a time, one manual at a time, one operator at a time. That infrastructure required a particular moment in American history. A generation trained by war, hungry to build, and willing to spend 100 hours on a project, because the project taught them something real. That moment has passed. The question is not whether it can be recovered. The question is whether anyone in power has any interest in recovering it, and what it costs the country every year that the answer remains no. If you built a Heathkit, any year, leave it in the comments. The model, the year, and what happened the first time you turned it on. I want to read everyone. This is the last frequency. Some signals take decades to fade. This one is still going.